All right. This is our first go at the second part of the title, which is equations. Now, that study sheet also has to be about all the things that are similar, all the things that are different. You're going to learn a whole different set of rules today because equations allow you to do things that expressions can't. Okay? And remember, an equation has an equal sign. Okay? So maybe you even have a little section on your study sheet. Can do this on equations, can't do this on expressions. Okay, why? Because there's specific questions to see. Do you know the difference? How to solve. And I'm willing to bet that there's going to be people going to the exam that are going to mix those up. Okay? What kind of thing have you put into place to remember to do it this for this? But don't do that. I can do it for this one. Okay? That is what's called synthesizing all the material at one time, which is difficult, especially in math when you do a different topic every day. Now, the first thing we're going to do before we even start, which may sound weird to you, we're going to actually show you how to do it on your calculator. Now, on a written response, how many people do the question in their calculator first before they start the written response? Yeah? Very few, hey? How many people, after they do the question, do the question on their calculator, and then draw the graph and write the correct answer that your graph gave you and say verified? Okay? Now, not many. And you know why? You don't want me to think you got the answer by your calculator. I did all this work here. I don't want to show you that I got on the calculator too. Okay? Now, that's actually a mistake. Write it down. Show that you've proved it. That instills confidence in me that you're getting full marks in that question. Now again, we're thinking, but if he thinks I did it that way, that means he's going to look through it carefully. He's going to see if I made a mistake. Okay, don't worry, I'm going to look through it carefully anyway. But putting that information, I've even had students put, I got the right answer through graphing, but I couldn't find it I made a mistake in my work somewhere. Right? That shows a different maturity than if you just do it all wrong. Change your answer and then walk. Because I'm not going to give you the mark for that. I don't know how you got that answer. Did you look at someone, across from you? I'd give you the mark, though, if you graphed it, drew the graph. I mean, it still worked and you did that, right? I'll give you a mark. Okay? It does show a different level of maturity. And, sometimes we just don't want anybody to know that we got it that way. There's times, too, that I don't know if you've ever done a research paper. And you do a research paper and say, I just throw it out there, smoking is bad, okay? So you're doing the research, smoking is bad. You think smoking is bad, I'm going in, smoking is bad. And you're doing some reading and you're on the web or whatever, and you find this study, okay, that shows all of this information, why smoking is good, okay? And you're like, oh, crap. Get that out of here. Get that out of here. I mean, if it was a newspaper article, you want to burn it. I mean, you just want to get rid of this information because it's not good. And it's funny because until my third year university, it's the first time I learned how to write a paper that I wish I would have known how to do that in high school. Because what the prof taught us was to do an essay. Like, say my essay was going to be why smoking is bad. He says, pick 3 points and support them why smoking is bad. I'm like, duh, right? I've always done that. And then he says, find 1 or 2 points why smoking is good. I'm like, I don't want that in my essay. Okay. Then he says, then do another paragraph saying, despite these 2 points, this is why I still believe smoking is bad. And then you defute those 2 points. And it was ingenious to hear that because I always used to avoid, I get rid of, whatever that. But what it does is it shows the marker you did look at both sides. And despite that information, I still think smoking is bad because what it does, it makes A, your essay totally well-rounded, but B, it's a different level of maturity. And even if you have a discussion with someone and they're for talking or for smoking, you're against it. Even in your debate, you can bring up, and I know the opposition is going to bring up that smoking is good for this, but we found 3 studies that actually show that that is incorrect. Now the other group is scrambling, Crap, that's what they're going to bring up. So even when you're doing this stuff and you can find counter arguments or you can find something that strengthens yours, put it in there. Okay? And even if it's not the answer you get, put it in there and say, even though, this is why. Okay? It does show a different level of maturity. Now, why would you graph it and stuff even before you start? Like, it's a written response. It's this long. I got all this room. I got to get out of here. Well, you don't want to go down the wrong road for a long time and then go and check it and go, oh, crap, I got it wrong. Okay? If you know the answer while you're doing it, it does focus you more because you're like, what? I'm not going to get it from that. Oh, yeah, okay, that's where I screwed up. It does help a lot, but it does take a different level of maturity because what do we want to do? We want to get going on it. It's written response. I got to write stuff. I got to have lots of stuff down there. He's going to be marking. He's going to see how much stuff I have and make sure all my numbers are right and everything, right? I'm not going to waste time graphing it. I don't get marks for graphing it, okay? But you actually do. If you drew the graph quick, drew your intersection points underneath, right, and they matched, okay, that is, it's obviously going to be worth some marks. Now, for this one here, the left side we're going to put into Y1, and the right side we're going to put into Y2. Okay? So if everybody just goes to their calculator, and how are you going to put that in? Well, it's 3 over x plus 1 in brackets. Now, if x plus 1 isn't in brackets, it means 3 over x, all plus 1. So you need to have x plus 1 in brackets, or else you're going to have a different question. Okay, and then hit zoom 6 after, and make sure okay, so if you graph it, you should have this. Okay? Now, depending on what calculator you have, if you have the 84, you even have a different picture than this. The 84 graphs it different, okay? The 83 plus puts in some information that actually, it's funny, the newer one doesn't do it. But first of all, I want to talk about this graph because looking at it right now, it probably looks like a total mess on your screen, okay? But can I just talk about the equation first? What is bad in this equation? So x cannot equal plus or minus 1, right? So where is x equals negative 1 is right there, and 1 is there. Now, the graph is not allowed to equal, or does not have an x of 1 or negative 1. So because those points do not exist, and what do you mean they do not exist? Well, if I put -1, then the answer doesn't exist. If I put 1 into this equation, the answer doesn't exist. So we represent that by these, okay? And if I can start to show you what this graph really looks like, it looks like now the blue is y1, and the black line there is y2. And the answers to this is here and here. These are the solutions, okay? The solutions are always where the two graphs intersect. Now we're going to be doing a whole unit on graphing next unit. So I'm not going to get into too much detail on how to draw these, but that's how it's going to look. Now, if I can get you to look back at your calculator again, you'll see what's going on. The two red lines that I was talking about, it's this one here and this one, and then it just stops. This should go all the way down, up, down. And you see how I have, see this part of my graph? That's over there too. Do you see this? Okay, that's supposed to look like that. That's in my graph. And do you see this here? That's all one graph. That's all y1. This is y2, x equal, or y equals 2. See that line there? And here, that point right, see where that line is? There's that arrow? Right there, and right there. There, and there. Okay? Those are my answers. Okay? And y2, maybe if it's going to help, I'm just going to make that a dark. But you see the first graph. There it is, then there, and then that part. That was the first graph. That's the second graph. And again, my answers are there and there. Now, how do I find that? Second, trace, 5. Now, I got close to the, you got to move your cursor left, right, till you get to that point there. See where it's blinking? Now, I'm going to just hit enter 3 times. Okay, so I got 0, 2. Now, when I did it last class, I got negative 3.16 times 10 to the negative 16. Now, times 10 to the negative 16, that means 0.000000, 15 zeros, and then 316. Now, when you have 15 zeros and then a number, essentially, what number are you? 0. So, this is the time that you learn that sometimes your calculator will not say 0 directly. It may say 3.18 times 10 to the negative 20. That means 19 zeros. Okay? So, and if it was to the 20, well, that's a huge, gigantic number. That's not 0. And then the other one, how do you get to the other one? Well, you got to go second, trace, 5, and then you just move left, or right, sorry. Right with your cursor, and then hit enter 3 times. Okay, so 0, 2, and 2, 2 are my solutions. So what are x's? X equals 0 and 2. Now, does anybody know do you see how the graph, it will go along this line forever, but it will never touch it? Because if it touches it, that means it is it. It is -1. Not allowed. Try it out. And over here, see how it'll go, it'll just touch it, but it'll just skim. It will actually never touch it, because if it does, now mine looks like it's touching it, right? But I am just trying to show you that it's just skimming along forever, will never touch it. Same with this, just skims along, never touches. Anybody know what these imaginary lines are called? They're non-permissibles when they are in the equation. They are called asymptotes when they are in graph form. So one time I was sitting here and I was going, you know what, they need to have a shirt that says don't touch my asymptotes, right? So, because you're never allowed to touch your asymptotes, right? Like, I don't know what you guys are thinking, but you're not allowed. And so I got that t-shirt from my students after, and they misquoted me, because that almost sounds like a challenge, but I didn't want a challenge, right? I said, don't touch my asymptotes. That's what I was saying, okay? So we're going to talk about those a lot next unit. Now, the other option you can do, and I'm not going to go through it because it is actually -2 to both sides, then you get it equaling 0, right? And then you can just do the whole thing, and what you're going to do is you will get, okay, with your asymptotes here, you actually get a bit of a different graph, okay? But wherever it hits the x-axis, because when it equals 0, we're using x-intercept. Where does it intercept the x's? Okay, so there's two ways to do it. I do prefer doing the y1, y2 way. This one you just do y1 and then find the roots or the x-intercepts or the roots, x-intercepts, or what's the other word? Zeros. Okay, they all mean the same thing. Okay. Now, we're going to start solving these mathematically. There's just two things that I need to show you before we start. Now, does everybody agree that 1/2 equals 4/8? Okay? Now, these are called in ratio to each other. What that means is one fraction equaling one fraction. If you have one fraction equaling one fraction, there's something nice that you can do. You can take the 2, you can move it up here, you can take the 8, and you can move it up here. So, according to this should be true. Is 1 times 8 equal 4 times 2? Okay? So that is what we call the cross product method. Basically, you're just taking the escalator from the down up, okay? And you take the escalator across the equal sign. In math, you could never take the elevator, okay? You can't just take something and move it above the fraction. Like 3/4, you can't just bring the 4 up. 3/4 doesn't equal 12, okay? The second thing that I want to talk about is, and this one is pretty sweet, 1/2 plus 1/3 equals 5/6. Now, in your calculator, can you just put 1/2 plus 1/3 and then hit math, enter, enter. 1/2 plus 1/3. Does it equal 5/6? Okay? Because you have to accept this as true before I move on. Do we accept this as true? Now, what is the common denominator of 2, 3, and 6? Okay, so common denominator is 6, correct? So if I know the common denominator is 6, I will multiply every one of these by 6. And then I go 6 times 1 divided by 2. So I'm right here. What's 6 times 1 divided by 2? So this is 3. Okay, what is 6 times 1 divided by 3? 2. What is 6 times 5 divided by 6? Okay? So, I have changed the equation to read 3 plus 2 equals 5. So what's the moral of the story here? In the first example, if you have one fraction equaling another fraction, there's an x in there somewhere, just multiply up and solve for x. Example 2, I have more than one fraction on a side. You just can't go cross product. So I find a common denominator. If I multiply everybody by the common denominator, a beautiful thing happens. I get rid of all fractions. And 3 plus 2 equals 5. Most people would not have to go to their calculator for that. If I said 1/2 plus 1/3 equals, people would be like, F56. Yes. Okay. That's what would happen. So, yet they mean the same thing. So, I'm going to use these two tricks for this whole assignment today. And you'll see it always works. Okay? Well, let's see what I'm talking about here. Okay. Why don't we go right to example 2. Now, do you see how A and B are very different? A is one ratio equaling one ratio. So we're going to use the cross product method. B, I can't do a cross product because there's two ratios on one side subtracting to each other, so I can't do it. So I will use the second method. Okay? Now, all you have to do, remember, this is in brackets, and this is in brackets, and this is in brackets. Okay? Those are in brackets together. So all you have to do is take this, move it up there, and this, move it over here. So 4x minus 2 times 3x plus 5 equals 2x plus 3 times 6x minus 1. So I guess I didn't have to draw such a long arrow, right? Just could have went right there. Now, what's cool about this is when you have an equal sign, you can do some nice things to get rid of fractions almost immediately. In expressions, you can't. You have to find common denominators, okay, if you're adding and subtracting. Like in B. Now B, we're going to find a common denominator, but we're going to use it against itself to get rid of denominators, okay? Now, we have to do FOIL here, right? So, let's just kind of go through it quickly. That would be 4x times 3x would be 12x squared. And then I would have 4 times 5 is 20. And then 20x and negative 6x would be plus 14x. And then negative 2 times 5 is negative 10. Okay, so I'm just combining the middle term as one step because we don't need to do a whole step with it. In your test, you might want to, but 2x times 6x is 12x squared. 2x times negative 1 is negative 2x. 3 times 6x is 18x. 18x and negative 2x is 16x. And 3 times negative 1 is minus 3. Now, they were nicely in factors. Why do I have to go and FOIL them together? You got to FOIL them so now you can get those two sides together. Okay? Now, something really nice happens, and what's that? Yeah, the 12x squareds are gone because they are the same on each side if I minus 12x squared to both. Now I have 14x minus 10 equals 16x plus 3. What I want to do is I want to get 16x out of the other side. I want to bring it over here. I want all my x's on the left. Why? I just do. I like my x's on the left. Okay, so that will be negative 2x. And then I'm going to add 10 to get that out of there. Add 10, and I will get equals 7. And then I'm going to divide by negative 2. X equals negative 7 over 2. Now, we're going to run into this more tomorrow, but you got to make sure that your answer is allowed. So, and sometimes that happens. You'll see that tomorrow. But what is not allowed? Do I even know what's not allowed? What are my non-permissibles? X cannot equal what? Negative 3 over 2 and negative 5 over 3. Now you're going to be making sure you find the non-permissibles and make sure your answer is not a non-permissible. Does it happen? Yeah. Is there going to be a multiple choice that will say no solution, or, say it says negative 3 over 2. You do all this work and you get negative 3 over 2. And then you look at the multiple choice. X equals negative 3 over 2. You're like, oh yeah. Circle it and you're done, right? You're moving on to the next one. And then you go out in the hallway. And they're like, did you get caught on that one? Where I got negative 3 over 2, and then I saw that was a non-permissible. So then I knew to pick no solution. And you'd be like, oh, I didn't even check. I didn't even check for non-permissibles. It was a multiple choice. It was right there. It was said B, negative 2 or 3, right? So, you've got to come into the test almost expecting there's going to be a question that is going to see, did you look for non-permissibles first? Because if you find your question says X cannot equal 2, and you got a solution of 2, is the solution 2? No, you're not allowed to use 2, okay? If you don't find the non-permissible, of course it's going to be 2. You're going to say it's 2 and life's good, right? Until you get your test back, and you're like, oh, crap, I got one wrong, and it was this one. I knew that, okay? I knew to check that. Okay, now let's look at B. B, I can't just go and do that. What I have to do is, what is a common denominator of t plus 1, t minus 3, and 1? Yep. So I always write it on the side. Common denominator is t plus 1, t minus 3 times 1 if you really want to. So what did I do in my little example at the top? I multiplied every term by that. So this is going to get multiplied by t plus 1, t minus 3. Oops. That doesn't look very good. T plus 1, t minus 3. This one, t plus 1, t minus 3. This one, t plus 1, t minus 3. So you have to do it to each term. Don't leave anybody out. Now, in the first term, is there anything that can cancel top and bottom? T plus 1, right? So cancel that one. How about in the second? T minus 3 cancels. How about in the third? 1 cancels, so nothing really. So this is what my new equation would look like. T minus 3, 5t minus 2, minus t 2t minus 1 times t plus 1 equals 3 times t plus 1, t minus 3. Okay, what's a good thing? I don't have to find a common denominator and change all of what I'm doing, is I just got rid of fractions. Now, it'd be nice to just add and subtract things, but I can't. They have to get into their cubes and squares and all that. Now, what you want to do is you want to be patient with this and this. Do not put it in. That's where a lot of you made a mistake on a quiz back 2 ago. Do the FOIL, then bring in the number on the outside, okay? So let's just quickly, this would be 5t squared minus 15t, or plus 15t. Just a sec here. Oh yeah, it's minus 15t minus 2t, minus 2t, minus 15t is minus 17t, and then negative 3 times negative 2 is plus 6. Minus. Now keep that minus sign and just do the FOIL. You get 2t squared plus 2t minus 1t is plus 1t, and then minus 1 equals 3. Keep it out. Now that's t squared, okay, minus 3t minus, or plus 1t is minus 2t minus 3. Okay, so you always have to FOIL before you get that number in. Now I'm going to take a whole new step to get the negative in and get the 3 in. So this isn't changing, 5t squared minus 17t plus 6. Now this is going to be minus 2t squared minus t plus 1 equals 3t squared minus 2t, 6t I should say, minus 9. Okay, on the left side, let's just get everybody together. Well, I've got 5t squared minus 2t squared is 3t squared. And then minus 17t minus 1t minus 18t. And then 6 plus 1 is plus 7. Okay? Now, 3t squareds cancel. Now I want all my t's on the left. I just like it that way, so I'm going to add 6t, add 6t. So that is negative 12t. Okay, and I want to get rid of that 7, right? Minus 7 equals negative 16. And I'm going to divide both sides by negative 12 because I want to solve for t, right? And t will equal 4/3. Okay, now is t allowed? Is 4/3 allowed? What are my non-permissibles? T cannot equal 3 and negative 1, so that would be allowed. Okay, just do one more quick question. This one goes quick. This one here, what's different about this one? Difference of squares. Get this done first. This is the same thing as x minus 4, x plus 4. Okay? It's hard to find a common denominator if you don't factor them first. What would be a common denominator? X minus 4, x plus 4. Okay, that's my CD. So I'm going to multiply this by x minus 4, x plus 4. This x minus 4, x plus 4. This one, x minus 4, x plus 4. Okay, the first one, what cancels? Okay, so they're gone. So that's 1 times x plus 4. Plus this one here, what cancels? X plus 4. So that's 2 times x minus 4. Equals, what cancels on this one? X minus 4 and x plus 4. So that just equals 5. This question is pretty easy if you know this step. Because this, what the equation now looks like, that's an easy grade 8 question. Right? All you do is multiply the 1 and the 2 and get all the x on one side, number on the other. Okay? So this would be x plus 4 plus 2x minus 8 equals 5. Okay, so that would be 3x minus 4 equals 5. Add 4 to both sides. 3x equals 9. Divide by 3. X equals 3. Is that answer allowed? Okay, why? X cannot equal negative positive 4, so that's good. It's allowed. Okay. So you have 20 minutes left. Some of you will finish. Yep. So we're doing questions just 1 to 4. Okay. So it's about 18 minutes of work, and you guys have 20 minutes. Hmm? No, do your homework first.